All right, so take a look at 29. W equals the square root of x squared times 5 to the x to the third. See, now that's great. I love that. So you love algebra too, as well. Also.
I wouldn't see how to do 3 halves.
Right.
3 to the...
3 times 1 half.
But now you saw it.
Can't we multiply by 1/3?
No. Yeah, sure. No, it's not to the 1/3. It's 1 half.
I make everything to the half, and then inside put times 1/3.
No, the third. When you cube something, it's not the same as taking the cube root. Okay, so they're different. So it's really the third raised to the half, and when we have an exponent to an exponent, the rule is you multiply the numbers. So this is 3 times 1 half. Okay, it's sort of like thinking about it as x squared times 5 to the x to the third, all raised to the 1/2 power, and you multiply exponents. Okay, so this was good. That was a good first step. And look, now you'll always see that step, right? That's something. It's a trick you've seen. You'll be good now. All right, so now I need to take the derivative.
So you do 3 halves times x squared times 5 to x.
Okay.
Whatever 3 halves minus 1.
To the 1/2. Now, that's where Johnny Shortcut would stop.
Yeah,
Johnny Shortcut would be like, I'm finished.
Oh, but then you just have to do the product rule with the chain rule, right?
Yeah.
I do get it now. Okay.
Wait, so now I
didn't get it.
So now we need to chain on the derivative of what's inside of what the inner function is.
And you have to use the
So
product rule to do that.
the derivative of x squared times 5 to the x, it's a product. First
X squared.
times the derivative of the second.
So ln 5 times 5, yeah.
Okay. Plus the second, which is just 5x. Derivative of the first is a little easier, times 2x.
And that's it. Oh.
And that's it.
I think I just got confused because the book put like the weirdest. Like,
So that's the chain.
the book writes it in strange orders and like that's not.
That's the product.
Right here, the plus 5x times 2x. So this whole thing is a product rule, chain. So the product rule says whatever the function is, in this case whatever x squared times 5 to the x is, I need to do the first times the derivative of the second plus the second times the derivative of the first. Okay, so that's this piece, that's that piece, that's that piece, and that's that piece. Is that alright? I would stop. I would quit while you're ahead. Steve.
Question. If there's anything like that's some quantity squared, can we just use the product rule instead of the chain rule? If it's like a big something squared, I'd like to use it.
So you can use the product rule, but to be honest,
The chain rule would be wouldn't it?
Like, could I just write it as 3x plus 10 times 3x plus 10?
yeah, I would even advocate write it like this. Write it as 9x squared plus 60x plus 100. And now you don't even have to do the product rule. All you need to do is the power rule. All right. Now, you're not always going to be able to do that. Like, well, is that true?
I mean, if it's squared, you can.
Yeah. If it's a simple enough thing that you're squaring, I would totally do that. I would expand it. But there are some people who, are going to say, you know what? I feel all right with the chain rule. I'm just going to use the chain rule because all I have to do is tack on the 3 at the end. And my guess is this. The chain rule is new. It's the newest rule that you have under your belt. All right. Of course, it feels the hardest right now. It totally does. I'll remind you that probably the day after we did the product rule, there are probably some of you that didn't really like the product rule, but now in retrospect, you're looking back and being like, oh, the product rule is so much easier than the chain rule. All right. I will say the chain rule, I think, is one of the hardest strategies we have for this chapter. After the chain rule tomorrow, the rules are going to get a little easier, but we're always going to have to ask ourselves, do I need the chain? Okay, so that chain rule question is always going to be in the back of our heads. What else? Or I'll just give you 15. I heard 21 and 33. 21 21. E raised to something? What's the derivative of e raised to something? E raised to something. Whoops.
Yeah, I think you do. But chain problem.
I'm actually seeing, so I have to chain on the derivative of this inner function. I'm seeing the derivative of 3w over 2. Just 3/2. Isn't that it? Isn't that the constant? So I'm just thinking times 3/2 and I'm done.
That makes it so much easier.
Now, could you have used the quotient rule to get the same thing? Yes.
This would take longer.
It would have been a lot longer and more simplification, but you totally could have used the quotient rule. You could have done low d high minus high d low over low squared, or Gixis, Gaxis, Faxis, Fixis, or whatever it is.
I believe Gaxis, Fixis, Faxis.
Which actually reminds me,
I really understood that.
I will, I'll get your quizzes back before you leave, but I do want to say, if you see something like, I don't know, something like this, you don't have to use the quotient rule. You can, remember the strategy, you can break it up into pieces. Right? That's another strategy you can use instead of using the quotient rule. You can break each of those up into separate pieces and then simplify the pieces and take the derivative of each
So
piece.
So ADX plus BB over D plus. I think it's easier to just use.
Okay, that's fine. It's all about options. And then, Nora, you said 30-something? 33. 33 is too hard.
Yeah.
Okay, well, I'll tell you immediately what Steve would tell you to do.
Yeah.
Just do X squared plus 2 over
Oh,
3.
okay. I can do it. Never mind.
Right? Like, so, yeah, like, I would FOIL, or actually, I would probably think about it first as x squared over 3 plus 2/3, and then FOIL it. But if you wanted to, you could, like, FOIL the top and do it all over 9. Yeah, well, it's the same thing, really, isn't it? Yeah.
You don't have to. Why don't we do it?
So you'd have x to the 4th plus 4x squared plus 4 all over 9, right? If you squared the top and squared the bottom, which is the same as x to the 1/9 x to the 4th plus 4/9 x squared plus 4/9. Wait, what are you woeing that? No, that doesn't get a woe. No, that's like algebra 1. Don't woe. Don't woe on that. Thank you. And then we have just 3 pieces that we can, take the derivative of by doing 4/9 x cubed plus 8/9 x, and this is 0, right? And we're finished, right? Now, that's not the only way to have done it. You could have done the power rule, and then you could have done the chain, and you could have used the quotient rule if you wanted to for the chain. Like, there are lots of ways of getting to an answer.
Your 4s and your 9s are really similar.
No, they do not.
Look at the one on the bottom. It looks like 8 over 4x.
What?
I was going to ask you why you didn't just put 2x there, but then
I think it's not blatant.
I mean, I knew.
Your 4s have tails.
What are you talking about? Here?
Yeah, the 4s
No,
have tails.
the 8 over 9 looks like 8 over 4 blatantly.
Yeah. No, that's not.
It's similar.
My 4s are so angular.
Yeah, they're angular.
Right.
Yeah, they got tails. Hello.
Right?
I knew 44. Yeah. Wait, I have a question about
Yeah. Go ahead. Hold on. Claire, before we do 41, go ahead.
Okay, yeah. So before that, so like just by doing the chain rule, can I look at it as the outer is x squared, and the inner is x squared plus 2 times, and off the quantity times 1/3?
I would probably look at it like 1/3 x squared plus 2/3 instead of doing it as another quantity. Like, I would look at it like that squared, and then you can do the power rule and then chain on the derivative of what's in the parentheses, which would be 2/3 x.
Okay.
All right. Is that okay? All right. 41 says someone 6e to the 5x plus e to the negative x squared. Okay. These look like 2 pieces that I have to do. I think I can do them. I don't think there's any algebra to do up front. 6e to the 5x. Someone talk me through the first piece?
5 times. Wait.
I'm gonna do the 6 first, but alright.
Yeah,
No. Yeah, dude, alright.
Well, isn't it just...
Which one is
I so want you to say it the way I want you to say it, and you're not. And that's okay.
I'll just stop talking.
But for what? What are the two products?
6 and e to the 5x.
You can do it that way. There's not a problem doing it that way because the derivative of 6 is going to be 0 when you do the derivative of the first. However, there's no need to use the product rule because the constant times a function is just that constant times the derivative. Okay, so I can say 6 times e to the 5x, but then I have to remember to chain on.
No, but that's what
The 5, you chain on 5.
Chain on a 5.
Isn't that what I said? 5 times 6.
It was. I didn't want. I wanted you to say it. I wanted you to put the 5 on the end, but like that's why I said you were saying it just not the way I wanted you to.
Okay.
Then e raised to some power, the derivative of e to something is
E to the negative x squared.
e to something, but don't be a Johnny Shortcut. You want to remember to chain on the derivative of the exponent. In this case, is negative 2x. And what's the derivative of negative x squared?
What rule do we just use? The chain rule?
Everything underlined is the chain. And I would actually, sorry, the compulsive side's getting me. Just one sec. I definitely want to make sure I put this in parentheses so it doesn't look like I'm subtracting 2x. That I want to make sure I'm multiplying by negative 2x. Go ahead, Claire.
Yeah, you have the dot.
I know, but I'm trying to show you that I want to be clear because I want you to be clear. Okay?
So if we do the chain rule first, what's the outer and the inner of that whole thing?
It's not a whole thing. These are two, because it's separated by a plus
You
sign.
don't need to do the chain rule.
Yep, exactly.
That's what we did.
Yep, exactly. Is that okay?
Yeah, that's better. Yeah, thank you.
You make it to sound out to be like you're more confused than you actually are. I'm just putting it out there because I think you're actually fine. You just you need it contextualized a little bit. All right. Anything else, or can I start giving you problems?
You've been giving me problems all year.
Oh gosh. Okay. Let's see. New sheet.
You still don't get it? You still don't get it? He's been giving me problems. I've been giving you problems. What'd you hear? You've been giving
That makes a lot.
Yeah, the other makes sense. Ew, that looks really weird. You swear? I never met you yet. No one's talked to them. Mr. B, do you have like a less than 10-second explanation on why we do the chain rule?
Because it doesn't help us in life.
Because you want the right answer. And we looked at, if you don't use the chain rule, you get the wrong answer. So Johnny Shortcut, never uses the chain rule. Because he always wants to do the quickest way possible, and he always gets the wrong answer. So the chain rule is there because it gets us the right answer. It's exactly what we need to chain on as a factor to get the correct derivative. And that's not really, it's not a proof, but oh no, there's a proof. It's not a proof that I'm prepared to give or you're prepared to receive. All right.
So the first one?
Who's up?
She's not. She's super good.
Eva,
What?
talk to me.
Can we just find the outer and the inner first?
No. You can. Do it in your head.
I don't know. Is 2 the outer?
I'm not talking to you. Eva.
Okay, it's a chain rule, right?
All right. That's fine. But I don't want you to say that this is a chain rule. I want you to say this is we're going to do this and then ... question do I need the chain rule? And then when the answer is yes, you use it. When the answer is no, you don't have to use it. So the chain rule is always going to be a question in your back of your mind. So we're not going to say this is a chain rule. We're going to say at the appropriate time, and now do I need the chain?
Okay. Okay, do I start out? I don't know where to start.
Aaron will help. Go ahead, Aaron.
There's too many options.
Evie, call on a little help just to get you started.
Alright. Can I make that 2 to the e3x?
What do you want to do?
That's definitely it.
Don't you like multiply when you take something to another?
No.
Alright.
Bring
Like-
down the e to the 3x and then do the.
No.
You keep it as 2e to the 3x.
That's what it is.
That's what I mean. No, that's what I mean. So you bring down the e to the 3x when you get the derivative, right?
I'm not there yet.
Oh.
We haven't done ... Do I need the chain? Steve, you want to keep going or not really?
I don't know.
Claire.
Wait, wouldn't that?
Okay, so I would say, so for the first part, just do the derivative. So it's just it's like saying 2 to the x. So
Okay.
So 2e to the 3x. And then just chain on.
I'm not ready for the chain yet because I haven't
I
taken.
thought you just asked about.
I know I haven't done the derivative of 2 to the x yet. The derivative of 2 to the x is 2 to something, but you're not done.
That is the derivative.
Not
No.
okay. Nora reminds us you need the ln of the base. Okay, so that's the derivative, and that's where Johnny Shortcut would stop. Johnny Shortcut would be like, 2 to the something. The derivative is ln 2 times 2 to the something. All right.
Then chain on.
All right. Now I'm ready for a chain. I need.
Derivative of e to the 3x.
What's the derivative of e to the 3x?
3e to the 3x.
The derivative of e to the 3x is e to the 3x.
Oh, but there's a double chain thing. Right?
But, and this is where I think Claire was going to be right first, but I now need the derivative of the 3x.
No way.
It's a double
It is, right? So there's the 3, and that's a double chain. So
Is there parentheses around the e and the 3?
There doesn't need
like
to be
there,
It's multiplication anyway.
so I'm never gonna. Oh, like are you saying, like should I put it like this?
No.
No. What do you?
Erase the middle one.
Whoop. Sorry.
It would be like
Doesn't have to be. Could be. Doesn't have to be. Okay.
Stuff like that. Johnny Shortcut. He's done before everybody else, right? You
Yeah.
don't even have time to tell him that he's wrong because he's already out of there.
Could be. Could
Really,
be.
he knows what he's doing. Like he knows how to. He's beating the system.
No, he's not.
He is.
No, he's getting the
Like,
wrong
he-
answer.
Yeah, but he's not. You can't. He doesn't.
Oh,
know
so-
he's wrong. He doesn't know he's wrong because he's already gone.
But why do we have
Holy.
why we have to
I think
change
he knows-
it?
I think
Why
he's
do
got
we
the
just
right
leave
idea.
it without the times 3 on the end?
You could leave it without the times 3 on the end. You'd just be wrong. Like, that's what it is. Like,
I'd be
on Friday when we went through all those examples, we saw that if you forget the chain, it's wrong. So that was sort of like a proof by counterexample. Like,
So that 3 is the derivative of the inside.
the 3 is the derivative of the innermost composite function. So if you think about what you're doing to x, the first thing you're doing to x is multiplying by 3. Then you're taking e and raising it to that power, and then you're taking 2 and raising it to that power. So we actually have a triple composite function, which means we're going to get a double chain. All right. Who's up next? You know what? There's no way I'm going to be dumb.
What did I say? Let's do the 9.
Or to the 4th, whatever you prefer.
If that looks like a 9, I can
Like you could probably prove that it's the same.
All right. All right. Who's up? All right. Let's hear it.
Alright, so 9. And then the inside of that. X, E,
All right.
and then that's where Johnny's shortcut would stop.
That is.
But you have to multiply it times the derivative of the inside, which is x e to 2x.
ln x. Is it ln x first or not?
Yeah, why is ln x?
Why is that?
Because it's
Constant time.
Well, then is it x? Oh, yeah, that's why
times
it's
e to the
this.
5x.
No.
Wouldn't that be 2e?
Times b.
I need to find the derivative of x times e to the 2x. I need the product rule.
Yeah, isn't that the derivative of the, or the function
First,
times the
what's the derivative of e to the 2x? e to the 2x. Go ahead, Dom. Times.
I was going to say it was 2x e to the 2x.
Okay, I'm going to put, you're absolutely right. I'm going to put the 2 here. Okay? Because that's the chain of e to the 2x. So I have the first times the derivative of the second. So that's first. This is derivative of the second.
Yeah, why is that the derivative?
Because this is a product.
Yeah, where's
Isn't that the derivative of the first?
No. Okay. Here's we really need to separate in our mind the difference between terms and factors. Okay? When we use the product rule, we're talking about factors. X is the first factor, e to the 2x is the second factor. Okay? E to the 5x is the second term. When you have a term, you're adding or subtracting, that doesn't use the product rule. So we're using the product rule with the first and the second factors. Okay? Wow, that was going to get fun too. All right.
That's just too much.
I'll talk you through it if you want to see it. You're welcome to go if you want to go. First times the derivative of the second plus, if you're gonna, and if you do want to go, just do it quietly because some people want to see the end. Plus the second, which is e to the 2x, times the derivative of the first, which is 1. I usually wouldn't write the 1, but because it's helpful to see it, I'm going to write the 1. All right.
E to the 5x times 5.
All right. So that's the product rule. Plus, now I have to do the derivative of e to the 5x, which is e to the 5x, and then chain on the 5. That's a chain. And we're finished that.
I just like this intensity.
I can't tell if you're serious or sarcastic.
I'm serious.
All right, good.